Welcome to this video, students. As in this video we will discuss about the models of an atom. So now we know, earlier it was known that this atom was the smallest particle of matter, but later discoveries leads to the information that atom is further subdivided into subatomic particles. These are electrons, protons and neutrons. Means still now we know that atom is further subdivided, but how these three particles are arranged in an atom, so we will discuss or we will study in this video. Here we will discuss about main three parts. The first one is the plum pudding model given by Sir J.J. Thomson. The second one is Rutherford's alpha scattering experiment and the concept of atomic number, mass number, isotopes and isobars. In 1903, Sir J.J. Thomson, after the discovery of electron, proton and neutron, put forward a plum pudding theory. As it is a theory, no experimental verification is there. So in his experiment, as you can see in the picture given, he explained that an atom is like the pudding in which positive and negatively charged particles are spread in all directions. The positively charged particles are protons and negatively charged particles are electrons. The number of positively charged particles and number of negatively charged particles are same as they cancel each other's charge. Hence it proves that an atom is electrically neutral. In the alpha scattering experiment, Rutherford took a very thin gold foil and bombarded alpha particle on it. Here the meaning of bombarded means constant striking. These alpha particles were released from a radioactive element. These alpha particles passed through the gold foil. Here I want to make it clear that the gold foil is same as that of aluminium foil, but that was made up of gold. And when alpha particles passed through the gold foil, they were made to strike the zinc sulfide screen. So in the end what you are seeing here is they strike with to a screen which was coated with the zinc sulfide. Certain observations were made there. Most of the alpha particles passed straight, as most of the scintillations were produced right behind the gold foil. So it shows that atom has space. Very few alpha particles were deflected through some angles. So it shows that the nucleus is positively charged. Very few alpha particles retrace their path as negligible scintillations were produced. This shows that nucleus is hard and dense. So overall, Rutherford's model explained that an atom has empty spaces in between the particles, that is between electron, proton and neutrons there are empty spaces, and the center of the atom, that is nucleus, is positively charged and is very dense and hard. And moving on to the atomic number. Now we know that atom has subatomic particles and it has electrons, protons and neutrons, in which electrons are negatively charged, protons are positively charged and neutrons are neutral, means they do not carry any charge. So now what is an atomic number? Atomic number is equal to the number of protons present in the nucleus of an atom. Means if the number of protons present in the center are 2, this means that the atomic number will be 2. If the number of protons are 4, then atomic number will be 4. So moving to the mass number is the sum of number of protons and number of neutrons. Here we are not considering electrons in this because electrons are negatively charged and the mass of anything can never be negative or 0. Atomic number is always designated as capital Z, whereas mass number is written as capital A, and mass number is equal to number of proton, that is small p, plus number of neutron, that is small n. There are certain atoms of the same element which have different mass number. They always used to have same atomic number, but sometimes their mass number varies. So these different type of atoms of the same element are designated with the different names. Here we will discuss about the isotopes. Isotopes are the atoms of the same element having same atomic number. Make it very clear that they are having same atomic number but their mass number is different. Moving to the isobars. Isobars are the atoms of different element. If they are of different element, it means their atomic number can never be same. So atomic number is different but their mass number is same. They are called isobars. Moving to the isotones. Isotones are the atoms of different elements having same number of neutrons, means they do not have same atomic number, they do not have same mass number, but they have same number of neutrons. So in this video we discuss the various models given by the different scientists explaining the structure of atom. So it shows that the atoms have the 3 subatomic particles. These are arranged in a particular manner in an atom. An atom has the atomic number, mass number, and then further leading to the isotopes, isobars and isotones. So here I expect that all these concepts are clear to you. For any query you can message me anytime. Thank you and have a wonderful day.